Hello students, let's talk about how we do these conservation of energy problems. So in this first option, we'll call this option 1. Here are the steps that we want to use, and it should look a little bit familiar because they're very similar to the conservation of momentum problems. We want to draw a before and after picture, right? So that's the same as when we had our conservation of momentum problems. So draw the before and after picture, make sure that it's neat, and make sure that you give yourself enough space so that you can do calculations on the before or after side. And then what we want to do, depending on the problem, is we want to find the total energy before or after, right? So it'll either be kinetic energy or potential energy. And the way that we do this, it will depend on the problem, right? So we'll do an example to show that in just a moment. Then we want to use that energy to find the unknown. So if we find the total energy before, that has to be the same as after, so that we can find our unknown in the after side. Or it might be a problem set up where we have the information to find the energy in the after side, and we want to find something on the before side. Right? Typically what we want to find is we're going to find either initial speed or final height. That's typically how we do these problems. It's not always the case, but that is what we'll find most of the time. All right, so make sure that you have these energy conservation problem steps copied down so that you can use them for reference. And let's get started on doing our practice problem. Hello students, let's do our conservation of energy problem. So we want to draw our before and after picture. So for this problem, what we have is our toy car. So here's our toy car, and it's 2 kilograms. And this toy car is moving along the floor with an initial velocity of 1.5 meters per second. And then the toy car encounters some sort of a hill or ramp, and it goes up the hill. So it's still 2 kilograms. And then it comes to a stop. So our final velocity is going to be 0. So here is our before side, and then here is our after side. So what we want to do is we want to add a little bit more information. Because we're on the floor, we're going to say that our initial height to begin with is 0. And we're going to say that up here, our final height is what we're trying to find. Now, what we can do for this one is, because we know our initial height is 0, and you have to have height to have potential energy, we know that our initial potential energy is 0. And then up here at the top part, because we're not moving, and you have to move in order to have kinetic energy, we know that our final kinetic energy is also 0. And so hopefully what you can see is that because we're moving over here, we've got kinetic energy to start with. And then because we're way up here now, we want to find out how high we went up, we have potential energy to end with. And that's what's happened, right? We've taken our kinetic energy that we're starting with, and we're converting it all the way to our gravitational potential energy. So what we want to do is we want to find at the bottom part on the before what our kinetic energy is equal to. So kinetic energy we know is equal to 1/2 mv squared. And this is the initial kinetic energy, so I'll use my initial speed. So let's put all the numbers in here. Kinetic energy initial, we've got 1/2. The mass of this car is 2 kilograms. And it's moving along at 1.5 meters per second. And don't forget, we have to square that to find the energy. So this tells us that our initial kinetic energy, when we put all these numbers into our calculator, is 2.25 joules. So if we started with this amount of energy, and energy is always conserved, then we would end with the same amount of energy over here. But now, it's not kinetic energy, we've changed it into gravitational potential energy because we increased our height. So that means our final potential energy has to be the same, 2.25 joules. And since I want to find height, I can use my equation for potential energy. It equals mgh. Now I can use my circle trick for this one. I put potential energy on the top. I've got m, g, and h on the bottom. And since I want to find what my height is equal to, if I cover up height over here, I'm left with potential energy over mg. And of course, I'm looking for my final height, and so I'll use the final, that's supposed to be an F, the final potential energy. So here's the equation that we can use then that will solve for this problem. So let me put the numbers in then. Our final height would be equal to, well, we've got our 2.25 joules, and we'll divide that by our 2 kilogram mass times little g, which is always 9.8 meters per second squared, at least on our planet. If you happen to be a Perseverance rover, it's 3.7. Just throwing that out there. So we put these numbers into the calculator, and it gives us 0.11, and we're going to use meters for our unit. So there you have it. We've got our before and after picture on how we solve a conservation of energy problem. I will see you in class.